We're doing the M2 Edexcel June 2015 paper in this video. Probably only get the first few questions done. Let's see how we go. First question is a power question. We're given, it's obviously an inclined slope, we're given an angle, we're given the weight of a van, we're given that has this constant resistances, we're given the power that the van is working at. Key thing here, moving down the slope. So we've got a van moving down the slope. So resistances are going to tend to go that way. So that's 570 newtons. There's going to be some driving force pulling the thing forward. There will also be a component of the weight down here. There's obviously a force here as well, but we don't need to consider that in this model. So we've got 900. The weight is 900 G. That pretty much sums it up. And we want to find the acceleration. Just 5 marks. Power questions normally always involve using P equals FV. Power equals force times velocity. Which in this case is going to give us the driving force, because we'll have 12,500 watts, which it's working at, times by force, times by the velocity. I haven't mentioned the velocity yet, but it's going down at 5 meters per second. So that's 5F. That gives us F is equal to 2,500 newtons. Okay. Then we're going to apply F equals MA down the slope. So the thing that's pulling it down the slope is the F, which we've worked out, so I might as well write it in, 2,500, plus the component of the weight, which is 900 G sine theta. I know we know sine theta, but we'll just we'll substitute that in the next line. Take away the resistances, which are going back to it, which is 570, is equal to mass times acceleration. And the mass of the thing is 900, and we're also, we're trying to work out the acceleration. So we're going to sub in, well, that's going to give us our acceleration in one go, isn't it? If we work that out, let's sub in for the sine theta here. We have 2,500 plus 900 times 9.8 times by sine theta, and that was 1 over 30. 1 over 30 minus 570 equals 900A. Okay, right, overwhelming temptation to do a bit of cancelling here, even though we're allowed to use a calculator. Please forgive me for this. A lot of people don't bother these days of calculators, but I'm old school. I do a bit of cancelling. So that's that's basically divided by 10. I've also got another factor of 10 there. So I'm going to work these bits out. So let's just reverse it now. We got 90A is equal to 222.4. So A equals to 224.4 divide 90, which gives us 2.47 meters per second squared. You're normally forgiven for not giving units in M2, but you're not forgiven for over accuracy, so we're allowed 2 significant figures here. So we could have 2.5 if we wanted, but we wouldn't be able to have 4 significant figures, but it's not relevant here anyway, because it works out exactly to correct. Okay, so that is that question done. Let's just see what question 2 has in store. Okay, question 2 is centres of mass. We've got this composite mass shape and we can split it in many different ways. We could split it into 3 triangles if we wanted to. We could split it into a rectangle and 2 triangles. Or we could do this. Split it into the whole rectangle here, but minus the triangle here, which is what I'm going to do. That's the way I'm going to do it, because it only involves 2 equations. Let's look at the masses of these things, the areas. The area, let's change back to blue. The area is equal of the square ADCB is equal to 4a squared. The area of the triangle ADO, well, that's obviously got a length 2a there, that's got a length there of a, so that's equal to a squared. So the ratio of the masses is basically 1 for the triangle, 3 for the whole shape with the triangle taken away, and 4 for the square. Okay, let's just look at the distances that these have. Well, 3 is the composite shape. Let's call that, because it's vertical, so we call it y bar. Doesn't really matter, but because it's vertical, let's call that y bar. And the triangle bit that's taken away, that there is going to be 1/3 from here, so that distance there will be a over 3, because it's 1/3 from the base. So this distance here is 2/3, so that's 5 over 3a. And of course, from the 4, we've got the, I'm going from the bottom here, it's going to be equal to a. Okay, so I'm setting this up so I'm not putting a minus in. Basically, we've got this times this plus this times this is equal to this times this. Because, and the reason why the structure is like that is because this bit is actually the whole. Often the way I think about this is, imagine you had the centre of mass of the composite shape with unknown y bar. Imagine we then added on a triangle, we kind of filled that bit with that. Then we would end up with a square with known centre of mass of a. So I just tend to avoid putting minuses when I write it up. It's just old habits die hard. I know the textbook puts minuses in and people use formulas, that's fine. Anyway, so let's just do this. So it's 1 times 5 over 3a plus 3 times y bar is equal to 4a. So 3y bar is equal to 4a minus 5a over 3. So that gives us a y bar, because that'll be 12a over 3 minus 5, that's 7a over 3, so that gives us 7a over 12. I beg your pardon, 9 of course. Okay, so that we're nearly there now, because we've got y bar, this distance here from the centre of mass, y bar, is equal to 7a over 9. So that means it's a distance from O is equal to A, because that's this distance here, minus 7A over 9, which is 2A over 9. And it's positive. That's basically, you don't need this to write to get the answer, but it's below O. That's the key. It's below O, so it's below it there. Right, okay. The part B of the question might just get a bigger diagram working here and do a little bit of tidying up. Oh, that's a lot nicer. The question now says the whole mass, the weight of this thing is, the mass of it is M, and then it says that it is freely suspended from A. So let's just draw that a line in to represent the vertical line. If it's freely suspended from A, that must mean that this line here, it represents the downward vertical. That must mean the centre of mass of the composite shape, and I think it says that we've got a mass of Km marked here. Now I'm going to mark this down here, just it's slightly exaggerated how far down it is, I think, but just so I can see the diagram easier. That's the centre of mass of the whole shape here, and we know that this length here is the 2 over 9A that we've just worked out. Okay, so we should be able to do that to set up a moments equation. This is probably the most efficient way of doing this, but a good diagram is essential to do it this way, because what we need is the perpendicular distances. Now, let's just mark this on. Let's mark in green. This distance here is the perpendicular distance from Km to 0. Now, looking at that, that's not particularly difficult to work out, because this is A and that's A using Pythagoras, that's root 2A. So that's the perpendicular distance of Km to the vertical line. The perpendicular distance here we need is that distance there we're looking for. Well, we can see some angles. We can see that's 45, for example. See that angle's 45. So, oops, that's the same. We can set up a moments equation about A, because moment, remember it's the perpendicular distance. So we've got M times by the perpendicular distance. So this M here. Oh, what I should say is, what I should have said is that the composite shape is going through the combined of those two is going through the centre of mass. So this is the centre of mass of the whole shape, which of course would be 1 plus K would send of the two bits together would go through there, and because of that it's the perpendicular distances that we want, because for it to balance out. So we've got M times by cos 2 over 9A times by cos 45. That's that distance here. Keep marking on. Equals this distance here, the Km times by root 2A. I haven't bothered putting G in. If I do put G in, it's going to cancel. I've just put it back in. Said I haven't bothered. I don't normally bother writing G in my moments equations with centres of mass questions, because it just cancels anyway. In this case, M cancels as well. A cancels. Cos 45 is 1 over the square root of 2. So let's see what happens. 2 over 9, 1 over the square root of 2. Is equal to K, the square root of 2. Taking the square root of 2 to the bottom, that gives us K equals 1 over 9. I think that's the quickest way of doing it. There is an alternative, which involves setting a table up and using the fact that the centre of mass x bar and y bar have to be equal, which is an alternative. You'll see that, if those of you get hold of the mark scheme, will see that as an alternative. But I think it's a little bit slower than this method. Okay, so that's question 2 done. Let's see what question 3 has in store. Okay, so it's momentum and impulse. We've got a particle of 0.75 kilograms moving along with velocity 4I in this direction, so it's in that direction. It then receives an impulse in the direction 6I plus 6J, and then after that impulse it moves with some velocity v. Let's call that v. Okay, let's use the impulse equation, which is impulse is change in momentum, mv minus mu. So we have 6I plus 6J equals to 0.75. Let's take that out of the bracket. V, take away u, which is 4I. So divide by 0.75, 6 divided by 0.75 is 8. Is equal to V minus 4I. So V is equal to 12I plus 8J. So now we've got our triangle, 12 there, 8 there, this is V. So we can say that tan theta is equal to 8 over 12. So that gives us theta equals to 33.7 degrees. And we need 3 significant figures. There's no G involved. Okay, so 33.7 degrees. Then part B, about kinetic energy. So this impulse here is increased in energy into the system. Now, I tend to it's perfectly okay to just look at the components here. Just deal with the components when we're looking at K gained. So KE gained will be equal to, remember it's half times by, because there's only one particle involved, 0.75. I'm just going to put all the velocities in as one single bracket because there's only one particle here. V squared, which will be this V squared, which is 12 squared plus 8 squared. No need to square root it, just to square it again. So it's 12 squared plus 8 squared. Take away 4 squared. Nice, easy source of marks, that really. That gives us 72 joules. Okay.